Hello and welcome everyone to my session on the bigger picture for model serving, monitoring and traceability. So welcome to the AIIA Mini Summit. This talk is going to be about the bigger picture and I'm going to tell you very shortly what that's about. So first off, who am I? Who is this guy sitting before you? I am a developer advocate, also called an evangelist at ClearML. ClearML is an open source MLOPS platform, right? I have about 4 years of ML engineering behind my belt, which gives me enough time, or has given me enough time, to know exactly how annoying some things can be, and also how actually really useful these kind of tools can be. I'm also making several YouTube videos, training videos, blog posts, training code and stuff like that. And then something personal, love tinkering and making with ML. So yeah, there is a YouTube channel, ML Maker, that we are working on with ClearML, just to make some things with machine learning. So that's pretty cool if you're interested. But for now, we're going into, well, model observability, but the bigger picture of that. So when I'm talking about model observability, what I actually want to go to is traceability, like complete traceability. And what I mean with that is that if you have an end user, for example here, you serve a machine learning model to them, one of many in your model repository. And then if something goes wrong, your model starts to drift, your data starts to drift, anomalies occur, you have to detect those, or your model just simply fails, there is model monitoring you have to do on top of that stack, right? So if you're serving the model, you better do model monitoring as well to catch these type of things. But what I mean with traceability is something much broader. It doesn't stop with model monitoring specifically. What I want is a complete trace back all the way to the original experiment. We call it an experiment, essentially the code that created the machine learning model, all the way back to the original data that was used to create the model as well, together with the code, right? So in this talk, I'll be talking you through essentially the model monitoring itself, but also how it connects all the way back to the very first stages where the model was first produced, and hopefully give you a better overview of what went wrong and how to fix it, right? So that's what I mean with traceability. We're going to go into a sample use case here, so I'm not going to go into slides much longer. I'll give you the tried and true demo. So just though we have to talk something to talk about though, I'll introduce you to the use case very quickly. So what we're going to do today is asteroid detection, which is really cool, but it's structured data. And this is an example of what you'll be seeing throughout the demo. It's essentially just a large data frame, let's call it, of specific features. So for example, absolute magnitude or estimated diameter in kilometers of specific asteroids. Each row is an asteroid that corresponds to all of these different features. And our goal here is to detect whether or not this row, this asteroid, is hazardous or not based on all of these features, right? So this is the model that I trained, that I deployed, and that I'm also currently monitoring. And then we'll see how this whole chain fits together. Now, to give a diagram of this whole chain is as follows. So we start with the model monitoring. I'll show you it in a little bit. Actually, in ClearML serving, so that's the serving engine that we'll be using, model monitoring is based on the open APIs that the serving engine delivers to you, right? So model monitoring will be doing it in Grafana, but you can essentially plug in your very own system. It's fully open source. You can attach anything you want to it. So you're not limited to any single tool. Then, of course, you have the serving engine. Whatever serving engine you might end up using, the main constituent of every serving engine is, of course, your model artifact, right? So your actual model file that will then be served as an endpoint, either HTTP, gRPC, or something similar, where users can send requests and get the return or like the prediction of the model back out. So that's what's going to happen in the serving engine. But then we can start to ask the question, right? To go further down this cascade. So if you have this model artifact, where does this model artifact came from? Like if this model is starting to drift, we really actually want to know what it was trained on, the original data, so we can compare and stuff like that. So where does this model come from? in this case, for example, it came from a pipeline, right? A pipeline here is in dashed lines. You don't have to make a pipeline, obviously. You can just make it from code. But a pipeline can be very, very useful to automate a lot of stuff. And so we will track this model artifact that we then served all the way back through the pipeline. But then a pipeline is also only just a collection of steps, right? Every part of the pipeline has to come from somewhere. And in the case of ClearML, and this is actually not trivial, in the case of ClearML, these steps are actually tracked experiments from the experiment tracker, right? And this is something that you don't see very often. Usually what you'll do is you'll experiment a while, you'll create your experiments, you'll track them, you'll compare them, you'll find the best models, and then you'll write new code that is productionized to be able to create a pipeline and actually serve the model as well. And in this case, this step is seamless, right? Because what we end up doing is these squares, they end up being the actual experiments that you were tracking before. So then we get to the experiment and data tracking manager, like the experiment manager that ClearML also offers. And then under that, obviously, you have the source files. And the source files are what the tried and true, everything, we all know these. So in this case, it's getData.py, which will just download the data and create a new data set. Then we'll pre-process the data as well, just to get them into order for the model training. And then the model training itself will actually generate a model file. And if you track your model training with any experiment manager, you will also track your models themselves, like the actual model files. And now you end up with your model artifact that will all the way go through to be served in the model engine, right? In the model serving engine. You also have, of course, a CSV file or whatever kind of file you want to use. It could be images or it could be audio, whatever, and put that into a separate dataset version. Now, I'll be referring back to this pyramid, let's call it, while we go through the code and through the experiment manager and serving and pipelines. But enough talk for now. So it's demo time. If I go out of these slides and straight into the Grafana dashboard, this is exactly what Drift could look like, right? So like I said before, essentially what I ended up doing is I created a model monitoring dashboard in Grafana on top of the serving engine, the ClearML serving engine that I use to host my model, right? And what you can see here is two specific features from this data frame, right? And I monitor over time the distribution of these features when they come in to the model, right? So people are sending requests to the hosted model, and I want to see what the distribution is of the data that comes into my model, because I know what the distribution is of my model when I trained it, right? And I don't want that to drift away. And so essentially what you're seeing here is a histogram of the distribution of these features, but then on its side, so that you can have in the x-axis the time, right? So over time, you will see that how a specific distribution changes. And as you can see here, well, quite obviously the distribution does start to shift, right? And here it's actually very obvious. So for the absolute magnitude, it's just very, very obvious that even the mean has completely shifted from what it was before, right? So these are the kind of scenarios where you actually do want an alert, which Grafana, by the way, can do. It just can send you an email or integrate with Slack. It's all very seamless. So you get the alert, right? And this is where we're at right now. We get the alert, something has gone wrong, we've detected the drift, and now it's time to actually use some of the observability that this pyramid gives us to go back to the original cause and hopefully fix it, right? So what we can do then is go to the next step here and take a look at the actual serving. Now, in ClearML terms, you get a bunch of tasks. You always get a bunch of tasks in a list overview, let's call it. And this is actually the serving in this case. So you have a serving control plane. I won't go too deep into that. This is essentially just the object that we use to send configuration changes to, and it will sync to the other two. This is just the orchestrator, let's call it. And then we have two services that we that can do something here. So one is a statistics controller, and the statistics controller will essentially pump everything that we wanted to Prometheus. Prometheus then serves as a middle ground, a database for Grafana, right? So I essentially added minimum orbit intersection. These are so cool names. Minimum orbit intersection distribution and absolute magnitude distributions. I added them here in Prometheus, and I can do essentially whatever I want from that point on. I can add it to Grafana. I can add it to my own tools if I want to. And then I have the serving instance, and the serving instance itself is the one that creates the API, the thing that people will send data to, right? And in this case, you'll see that we have an XGBoost model served under Asteroid as the URL endpoint, right? And then immediately we start seeing, okay, this is the actual model ID, and it's a link. And if we go to the pyramid here, this is this yellow blob, right? This is the model that we're trying to figure out where it came from. And then if I click on that model, we'll go to a different list where we can see all the different data that we gathered when that model was trained originally, right? It's just being tracked all the way through. So you can see on which data it was done, and you can see in which framework, you can see the status. You can actually download it as well if you would just want to train it or like test it offline. You can see which tasks created it. You can see which project and so on and so on. But what is very interesting, also, if we have a deep learning model, you can see the model configuration or like the actual layers here. If you have any labels or metadata, you can also add it here. But then we want one step deeper, right? So if we go back to this pyramid, what we actually want now is to find the actual code, the actual tracked tasks that created that model artifact, right? So if we go to tag best model, apparently it's called tag best model, we see essentially an experiment tracker, right? So in this case, now we are at the level of the experiment manager. And what you can see now is that we have some source code, right? In this case, and I'll tell you why later, this repository is not filled in because it's a simple Python file that wasn't tracked. And I'll tell you later why. But also there's some uncommitted changes. If there is a repository Git, it's automatically tracked. There are uncommitted changes as well, right? Because you don't want to commit every single change you do. Because you don't know if it's going to be good yet, right? So this is why you have an experiment manager, so you can intermittently also save everything. And of course, it helps reproducibility. We can apply this patch, this uncommitted change, so that we can reproduce the code. It also tracks all of the installed packages that were installed at runtime, containers in which it should run. We also have configuration, for example, configuration parameters. In this case, this will become more clear when we go to the pipeline overview. And then, of course, we have artifacts. And in this case, this is the actual model that we came from, right, that we clicked on before. The console as well, you have console output. That can be very interesting. Every print statement that you have will end up here. And then you have scalars, plots, and debug samples, which will be empty in this case, again, because it's part of a pipeline that I will explain to you later. So if we go into the info tab, it can get actually quite interesting because, again, we know when it was created, when it was started, by whom, on which worker it was run, but also, and this is very interesting, we have the parent task. And in this case, we very clearly see, okay, it's actually a pipeline. It was created by a pipeline. So now we know that the model was actually created by a step in a single pipeline. I could click on this link, or I can go give you an overview. Like, this is a separate part of ClearML, which is actual pipelines. And if I go in here, I can see Asteroid pipeline, and Asteroid pipeline number 3 is the one that created it, right? And now things start to make more sense, because now we have the tag best model, which is essentially just a node in this pipeline. And these are the specific experiments that I was talking about before. So if you go here, you have get data.py, preprocess data.py, and model training.py, which are like a normal flow of a machine learning system. But those were tracked individually as experiments. And now I have added essentially a fifth, or like how much is it? Like a fourth step that essentially just takes the best model that was trained. And so what is really interesting is that we can essentially start to play with these experiments, right? So get data.py is actually very simple, right? It just gets some data and uploads it to a data set with a certain ID, right? And this data set, again, we can go look into and then find out what was in there. Does the distribution still fit or still hold up with what we saw in Grafana, stuff like that. So everything here is connected, right? The preprocess.data, again, is then a different file that just preprocesses all the data, and then it becomes really interesting. So if I take a look at these are essentially all clones. So at some point, I ran my model training while I was experimenting, and it started working. And then I took that, essentially, I took that experiment, that task, and then I cloned it 2-3 times and gave it different parameters. And that's what something that ClearML can do, is it can reproduce your code from the experiment time and then inject new parameters in there just from the UI, right? So what I could do here is I could say, okay, I want random state here to be 420, but I want random state here to be 500, and I want random state to be here to be 42. And then if I go to look into the code, I'll show it to you. So we have the model training. If you go into the code, we see here that we have a dictionary with all of these values in there. And then we start actually training that code. We start splitting it up into train test, and then actually giving those training arguments to XGBoost, right? But what happens is that if we change the random state here in the pipeline, it actually gets injected into this code. And this code then starts running from there as if this value was 500. And this allows us to do really cool things. In this case, we created 3 different clones, or actually not even different, 3 identical clones, and just injected different parameters in there. And then we made an extra function, which is simply a function, which is why it didn't have the repository, right? It's just an extra function as part of the pipeline that just selects which model was best, right? So we have now the best model. If we go back to the pyramid, right, we have our best model now, and I have the original experiment that trained it, right? I can even, what is actually really interesting is I can even go to the original task, which is here. If I click on full details, this is the actual training task, right? So this is where everything was trained. This is the original code. This is everything that we need. And if I go to the actual project that all of these experiments were tracked in, I can even select multiple of these nodes, right? These are the 3 nodes from our pipeline, and I can compare them. This is an experiment manager after all, right? So we can easily show different changes and highlight them. So in this case, for example, what we can see is, okay, we had different runtimes, we had even different worker. We can see that they were run on different workers. We can see different URIs. Where it gets really interesting is from the hyperparameters, right? Here you can see that the hyperparameters actually changed, and this is the 3 different nodes that we saw. And then you also have scalars, right? So scalars in this case are, for example, test and train RMSI, so, and accuracy as well. So we can see plotted on graphs the differences that the model gave us. And what is even more important, because this is an observability talk after all, we also have the plots as well. So for example, in this case, I plotted the feature importance of each model, or like actually of the model. It's a single experiment, and then it was cloned 3 times with the 3 different parameters. So we see the 3 different feature importances, and we just can compare them very, very easily, right? Now, back to the problem at hand, right? We still have drift in our model, right? So we have to find a solution to that somehow. And if I go to my pipeline here, what I can see is that not only can the task have a parameter, but the pipeline itself as well. And in this case, for example, the getData.py actually uses the pipeline parameter select star from df where year is smaller than or equal to 2021. And as you all know, we are 2022 today. So we actually want to change this, right? And then run the pipeline again, because we have new data. We can change it to include all of the new data as well, create a new model, and then deploy that as well. And that's exactly what we're going to do right now. But it can be very, very easy because, like I said, we can inject these new parameters. So if I click on the new run button here, I can change this to 2022 instead. And if I do that and run it, it will create a new pipeline right here with select star from df where year is smaller than 2022, right? And this will now spin up this will essentially clone the original experiments again and run them on remote machines using ClearML agent. This is out of scope of this talk, but essentially what it's doing is it's remotely running all of these blocks, and you can see it building up here. Now, this takes a little while. You have to set up the whole environment to be able to run an exactly replicated code from when it was before. So I've done that before with this pipeline. So this pipeline has as well select star from df where year is smaller than or equal to 2022. And what we can see now is that if we go to the tag-based model, go into the full details, and then go into the artifacts, we see here that it has a new model attached to it, right? So this is actually the model that has now been corrected for drift. We have trained it on different data, on new data that is more representative of the data coming in. And what I want to do now is get the F7 here, the ID, and copy it to clipboard. And now what we want to do is we want to be able to serve this model now again. So let me go to the console here. So what I want to do, ClearML serving, there we go, is, let me get rid of it for a little bit. There we go. So what I want to do is I want to add a new model to my original. Let's go back to the serving here. So these are the serving tasks. This is the service control plane. Remember that I told you that this is where we push configuration changes, right? So this has ID 44A, as you can see. So if I go into my command line here, you can see that we're deploying a model on 44A, which is the service that I just talked about. We want to add a model of Nginx GBoost with a new endpoint that is not called asteroid, but asteroid drift corrected, right? Because now this is our new model. We still want to use the same pre-processing. Essentially, in ClearML serving, you can add your own pre-processing, your own custom Python functions that will do pre and post-processing before it gets sent to the actual model. I'm just going to keep that the same because we trained on the same kind of data, so we don't expect any different format to come in. And now we have a model ID that is the F7D model, the F7D ID that we had here of the model before, right? So this is this one. This is the model that the new pipeline created. And then the project is the same project as before. So if I deploy that, what will happen is it will create a new endpoint called asteroid drift corrected, right? This does not necessarily mean that traffic is already routed to that new route. But what can be very interesting, so if I go to the serving plane, if I go to configuration, you'll see that the endpoints are now, we have now two endpoints with different model IDs. So it's very, very trackable. And like I said before, serving control plane is actually where we push our configurations to. So now it gets synced to the two different other containers or other tasks that are running every minute, because these can then hot swap these new endpoints, these new models, these new, whatever you change on the serving control plane will then be hot swapped by pulling these two. So these two will be pulling the serving. And so if I go to the plots, there you see it's already been synced. So now we have a second endpoint, which is called asteroid drift corrected, right? If I go to the overview here, you can see that we now have two endpoints on the same, essentially, server, right? But obviously, we don't want just everyone to go to the new endpoint all at once, right? That would just be bad. But what we can do is we can do a canary deploy, right? And that makes it very easy for us to check if everything is going well. So if I go into the terminal again, and I run ClearML serving, but this time I want to create a canary endpoint. Let me search for that for a little while. There we go. So this, what essentially this will do is it will create yet another endpoint called asteroid canary. It will give weights of 0.9, so 90% of the traffic will be routed to the old asteroid endpoint, and 10% will be routed to the asteroid drift corrected endpoint, right? Because this is a new model. We want to make sure that if 10% of the users are okay with it and we don't get any complaints, we can start rolling it out further. But this is a good starting point. Again, we're deploying this to the 44A ID, which is the service that we saw before, that we will push all our configuration into. So if I update this right now, there we go. That should have worked. So what again will happen is it will first be synced to the service control plane that will now have an extra canary endpoint, right? So the endpoint here states that, okay, it's an endpoint called asteroid canary. So this is just also / asteroid canary. And then here are the weights. So 90% of it will be going to asteroid, and 10% will be going to asteroid drift corrected, which are our two other endpoints or two older endpoints, as you can see here. And if everything is going well, it could take a little while until these sync. but it could be, there we go, it's already synced. So if I now go to plots, now we have an actual third endpoint called asteroid canary, right? And at this moment, we can be pretty sure that that this model can be either good or bad, but we're pretty much safe from there because it's only 10%, right? And if complaints start to get in, we can very quickly change it out for something else. So let us test this as a last step. So what I can essentially do now is send, this is running on localhost, obviously, send a request, sorry, on the asteroid canary endpoint right here with just some data, right? And if I do this and everything works, then you will see that, okay, this is outputting 1, but this is outputting 0. And statistically, what should happen is that about 1 in 10 will be 0, which is the new model, and 9 in 10 will be 1. Because that's the old model, right? And right now we have completely redeployed our model, and we can start rolling it out if it works well. And so just to go back here, what we've to recap what we've essentially done is we've found drift in model monitoring, right? But yeah, doesn't matter. So we found drift in model monitoring, right? So serving the model actually created enough metrics that allowed us to see that the model was drifting. And then we started to trace it and observe it all the way back to the original code that created it, changed some of the parameters there, rerun the pipeline, created a new model, deployed it as a serving new endpoint in a canary fashion so that we have like a decent split in traffic. And now we start to monitor the same model again for additional drift. So this is a nice workflow that allows you to end observe the whole chain and very quickly change it and very quickly iterate on it. So I hope this was very interesting. This is essentially the demo. The code will become available at a later moment, but this week normally. But so yeah, anyway, thank you so much for listening, and hope to see you soon. These are all of the sorry, let me give it full screen. So these are all of the contact details that we have. So you can find us at app.clear.ml, or you can get started for free at app.clear.ml. It is open source. ClearML is open source, and everything that is in green right here is ClearML based, right? The model monitoring itself is in Grafana. You can have a pre-made Grafana dashboard, but essentially you can plug in any tool that you want. Everything else is in green, is from ClearML. This is, of course, your own code. And you can get started for free. It's open source. Host your own server, do whatever you want. It's all up to you. And then obviously, this is the GitHub. We have a Slack page if you have any questions or help. And then also we make some nice memes. So you can follow us on Twitter as well, or myself at Victor Sok. So thank you so much for listening, and hope to see you soon.